Good day everyone. In this video, we are going to learn about the measure of dispersion. Firstly, let's have an introduction about it. We have learned about the measure of central tendency, that is mean, mode, and median. The measure of central tendency are not adequate to describe data, because two data sets can have the same mean, but they can be entirely different. This means the measure of central tendency may not give us enough information to do comparison. We need to determine the measure of dispersion of a set of data that can give an impression about the features of the data. This will be further explained. Thus, to describe data, we need to know the extent of variability, so the conclusion makes it valid and acceptable. This is given by the measure of dispersion. Range, interquartile range, and standard deviation are the three commonly used measures of dispersion. What do you understand about variance and standard deviation? Variance and standard deviation are the measure of dispersions commonly used in statistics. Variance of a set of ungrouped data can be obtained using the formula of variance. The variance is the average of the square of the difference between each data and the mean. An alternative, yet equivalent formula of variance, which is often easier to use, is variance equals to sum of x squared divided by number of data values, then minus the square of mean. From the formula, x bar is the mean, the average of the data values. N is the number of data values. X stands for each data value. This is a sigma summation symbol. For example, sum of x squared means add up of all the value of x squared. And this symbol indicates subtract the mean from each data value, square, and finally add up the resulting values. The formula for standard deviation. This formula is easy if variance is being calculated. It is the square root of the variance. The formula for standard deviation. The standard deviation is a measure of the amount of variation or dispersion of a set of values. The low standard deviation indicates that the values tend to be close to the mean of the set, while high standard deviation indicates that the values are spread out over a wider range. Let's work out a few example problems about the variance and standard deviation. Find the variance and the standard deviation for the data 20, 13, 5, 11, 7, and 10. We calculate the mean of the data given, that is the average of the data. X bar is the symbol of the mean. That is 5 plus 7 plus 10 plus 11 plus 13 plus 20. Divided by 6, we have a total of 66 divided by 6. The mean is 11. Now we calculate the variance with these numbers. Variance is represented by the symbol sigma square. So keep in mind the formula of variance equals to sum of x squared divided by number of data and minus the mean square. So first, we are going to list the data in ascending order and take the square of the number added together, 5 square plus 7 square plus 10 square plus 11 square plus 13 square plus 20 square divided by 6 and minus 11 square. We have 864 divided by 6 minus 121. The variance is 23. Next, we are going to find out the standard deviation. Since the standard deviation is the square root of the variance, the square root of 23 is 4.8. Therefore, the standard deviation is 4.8. Now, we try to calculate the variance of the same question in an alternative method. We have the mean of 11. By using the formula of variance, calculate the average of the square of the difference between each data and the mean. 5 minus 11 minus 6, 7 minus 11 minus 4, 10 minus 11 minus 1, 11 minus 11, 0, 13 minus 11, 2, and 20 minus 11, 9. And find the sum of the square of all the numbers. We have 138 divided by 6, the variance is 23. The table below shows the achievement of 2 pupils in 5 chemistry tests. One of the pupils will be selected to be represent the school in a chemistry quiz competition. Determine who is eligible to be selected and justify your answer. For this question, find the mean mark and the standard deviation of element. The means is the sum of 40, 70, 90, 85, and 64. Then divided by 5. The mean marks for element is 69.8. Now we are going to find the standard deviation. The symbol of standard deviation, sigma, equals to square root of variance. Substitute all the numbers into the formula. That is, the square of 40 plus square of 70 plus square of 90 plus square of 85 plus square of 64 divided by 5 minus the square of 69.8. Calculate by using the calculator, we get 17.67. The standard deviation for element is 17.67. For John, his min marks is 80 plus 65 plus 73 plus 58 plus 73. Then, divided by 5, the min mark for John is 69.8. Same as the min marks of element. Now, we are going to calculate the standard deviation for John. Calculate the average of the square of the sum of each data, minus the mean square, then square root the number of 10. Substitute all the numbers into the formula, then calculate by using the calculator. We get 7.574. The standard deviation for John is 7.574. If one of the pupils will be selected to represent the school in a chemistry quiz competition, we can see that their means are the same, but their standard deviation are different. Standard deviation is usually used to compare two sets of data. In general, a low standard deviation indicates that the data is dispersed close to the mean, while a high standard deviation indicates that the data is dispersed far from the mean. Therefore, John will be selected to participate in the chemistry quiz competition. The standard deviation of John's score is lower because John's achievement is more consistent. Here comes the end. Thank you for your participation and see you next time.